Julien for inviting me today and give me the opportunity to present what we do in this LabX. So normally I have 45 minutes. I'm not sure I will last so long. And I don't know how you work here, but I don't mind if you want to interrupt and ask questions during my presentation. And I will start with a little reminder of what a LabX is. I don't know whether all of you is familiar with this. Actually, a LabX stands for Laboratoire d'Excellence in French, Excellence Laboratory. And it is an innovative scientific project with an international range carried out by a group of research laboratories and financed by the French government as part of the Investissement d'Avenir program. So that's a big investment program at the French government. So a LabX is just a project. It's not a structure, actually. And we have 14 LabX on the campus of Grenoble. And Tec21 is the Laboratoire d'Excellence for Mechanical and Process Engineering. Since 2012, that's the year we started. Here you have the outline of my presentation. And so our LabX is the uniting of 9 research laboratories or teams, because some of the laboratories we have here are not entirely in our LabX. Here we just have a team, here as well. But it makes 250 permanent researchers and technicians, all of them located in Grenoble. Some LabX are dispatched over France, but Tec21 is located on site here in Grenoble. And of course, these people share tools, methods, and research objects. And we have received 9 million euro budgets over 13 years. So just a quick overview of the laboratories we have in Tec21. This one, you will hear about it this morning a lot, because most of the speakers coming right after belong to 3SR Lab, which stands for Soils, Solid Structures and Risks, doing solid mechanics mostly. We also have the LEGI, Laboratoire for Geophysical and Industrial Flows, so that's a fluid mechanics laboratory. We have the LGP2 for Pulp and Paper Science and Graphic Arts. These people are working on fibrous materials mostly, and process engineering. We also have the LRP for Rheology and Processes, working on complex fluids. A team of the Interdisciplinary Laboratory of Physics, working on cell mechanics, flow and cell, soft matter dynamics, physics of fluid movements. These people are working on soft matter physics. We also have a team of the CMAP laboratory working on electromagnetic processing of materials. We have the ECRIN team working on torrential erosion, snow and avalanches. These people belong to the UGA Institute. We also have the Department for Low Temperature Systems, located right there at the CEA. And recently we have integrated a team working on biomechanics of living tissues and materials for living organisms. But as you have probably understood so far, our LabX works on mechanics at different levels, at different scales, and different kind of physics, but that's the common thing of all our researchers. And the objectives of our LabX are threefold. We want to develop our research activities, encouraging interaction between our partner laboratories. You've seen we have 9 different laboratories, and the idea was to strengthen their interaction and to make them work together more. The other objective is to reinforce research-driven training programs. So I will show you we are also involved in education, as well as contribute to innovation, and in particular through collaboration with industrial partners. That's the three main pillars of what we do. So we have 4 scientific work packages dealing with the complexity of systems and phenomena involving strong couplings at different scales. That's what we do. We work on things where the functioning involves couplings at different scales. And we develop experimental tools and methods, as well as numerical models and simulation. So the first work package deals with the coupling of fluid and solid mechanics. We have different axes under this, like solids in fluids, fluids in solids. So I'm not going into details scientifically speaking, but this first work package deals with dense complex suspension, non-Newtonian fluids, particle transport, erosion, deposition. The second one deals with fluids in solid, and in particular highly confined flows where percolation in porous media occurs, and so on. The third one deals with solid-fluid transition and associated instabilities like shear bending, liquefaction, dynamical phase transition, etc. Fourth point, fracture and rupture, with fracture propagation, fragmentation, micro damage, things you will probably be going to hear this morning. And finally, flow structure interactions with deformability of matrix interfaces at micro and nanoporous system, etc. So that's the first work package. The second one deals with coupling fluid mechanics with biophysical phenomena at micro and nanoscales. So here we do advanced fluid mechanics, interfacial dynamics and transfers, and flow of active micro-objects like swimming of particles, biofilms, bacterial growth, etc. I've tried to illustrate what we do in terms of application, experiments, and simulation, because we always have these 3 things. The third work package deals with mechanics of and for the living matter. So in here we work on mechanics of the living matter at the cell scale and at the tissue scale as well. And we also work for mechanics for the living matter with biomaterials for prostheses, development of fibrous substitutes. That's the example here. We have in 3SR people working on the vocal folds, and they're trying to mimic what happens in our vocal fold to replace them in case of accident or whatever. So they need to understand what kind of material is on site, and then try to understand the mechanics of this tissue and mimic and reproduce to have this kind of thing. And we have a last work package that is transversal, dealing with advanced numerical tool and experimental methods. So this one serves the whole thing, because as I said before, the people working on our LabX share tools and methods, of course. And so we work on advanced modeling and simulation, multi-scale characterization and field measurements, and coupling with artificial intelligence. That's quite a recent thing we're trying to promote, because we have a couple of people here working here on these topics. So that's a couple of examples of things that were modeled in our projects. And mostly what we finance is research actions, fundamental research. So we have a yearly call for research proposals. All the projects we receive undergo an international peer review. So that's fundamental research. We don't do, well, on this call, we don't finance things with industry or industrial partners. And what we finance is mostly human resources, PhDs, postdoc, long-term visitors. So these people come to France to co-supervise a PhD student with a colleague from a laboratory. Short-term visitor, same thing. This foreign people, foreign researchers come to our laboratory to set up, to write down a project, to collaborate on a topic with the researchers from Tec21. We also have outgoing grants to give the opportunity to our researchers to go abroad and meet people from another university. And we also finance large equipment. So since 2012, we have financed more than 100 research projects in these categories. I will give you quick examples. So this one is a PhD long visitor. So this means that we hire a PhD here, but we have a collaboration with a foreign university, in this situation, the University of Oldenburg. And the researchers from there comes to Grenoble to co-supervise the PhD student. And this project dealt with the role of turbulence cascade in wind energy applications. So you can see you have a wind turbine farm, and the idea is to understand how the wake can change the conditions behind and see what's the best way of exploiting the system. This project is just a PhD student. So in this case, we just finance the PhD, and we have two laboratories from Tec21 co-supervising the PhD student. And this project is with the multi-scale investigation of the interactions between debris flows and obstacles through a coupled methods for modeling. So this involves Triacer and the INRAE Grenoble. This one is an example of a postdoc project. So our postdoc lasts for 1 year. And same thing, they need to have a collaboration between at least two laboratories of our perimeter. And this deals with the problem of modeling the forces induced on structures, especially dealing with avalanches and snow. This project is an outgoing grant, which means that a colleague from the LIFI went to the College of Engineering in Boston to work with a researcher there on the modeling of the hysteretic path in cycling deflation inflation of spherical shells. So this is this can be used to transport medicines in blood vessels, for instance. You produce little capsules and you can activate them with ultrasounds, for example. And they will go like this, inflate and deflate, and they will move. And so you can pilot them. It's like micro robots. Well, it's far away from being done, but that's the idea. That's a short visitor project, which means that the researchers from the Department of Microbiology went to Grenoble to collaborate with these two labs on the three-dimensional visualization and quantification of a biofilm growing on a porous media. So that was done with microtomography, and the idea was to be able to separate the porous media from the living organism and understand how it works, how it grows. The idea is to develop biofilters. And last, this is a big equipment we have been contributed to buy with a couple of other structures. It's an X-ray nanothermograph that is used by the whole community. So Tec21 will contribute to financing tools that will serve the whole community. Just to tell you, since we started now, we have between 70 and 80 publications every year citing Tec21 as a funding institution. That was not the case at the beginning because the colleagues, they tend to omit to cite Tec21 in their publications, but we insisted a bit, and now they do it. And so that's what we have yearly, between 70 and 80 publications citing our institution as a funding partner. And what we observed is that since 2012, we have been able to strengthen the interaction between our laboratories because among these publications, a good part of them is co-signed by people from at least 2 laboratories from our perimeter. And we also have been able to develop new collaborations with foreign university thanks to the long visitor or short visitor or outgoing grant program. So that's an overview of the different people around the world we've been working with since 2012, and we are still working with these people because most of the time Tec21 is just here to give the impulse to a new collaboration, and then this will keep going. About education, a quick word. We are strongly involved in education from the first university years up to the engineering degree and PhD level, of course, because we have PhD students. You need to know that every year more than 500 students graduate from the mechanical and process engineering education units. You're probably part of it. And that represents 200 technicians, 30 master students, 250 engineers, and 50 doctors, roughly. And so our objective is to attract brilliant students to prepare their second year of master in one of our education programs. So we have a yearly call for application, and what we do is we finance Master 2 scholarships. So we finance between 4 to 6 scholarships every year. More than 20 master students did a PhD after their master studies, and 12 of them in one of our partner laboratories since 2012. Well, one of the big problems today for the research community is to attract people in their laboratories. And that's the objective of our scholarship program. We also organize a winter school dealing with multi-scale approaches and multi-physics couplings in fluid and solid mechanics. So that's exactly what we do in the LabX. The idea is to give 1 week to students, engineers, or people wishing to reinforce their understanding of this topic. 1 week for connecting theory to experiment and numerical simulations. So we have a first day dealing with multi-scale approaches in mechanics. The second day dedicated numerical and experimental tools and methods. And then we have 2 days of practical sessions where the people go to the laboratories and work on experiments, supervised by, of course, one of our researchers. And the last day is dedicated to specific problems dealing with, for instance, mechanics at the nanoscales or waves in fluids and solid, instabilities in fluid and solid mechanics or fluid-solid transition, So that's a specific, and it changes every year. But the core here never changes. So the next edition will occur in February 2015 and 25, sorry. And this is important because we have built up 10 demonstrators, so it's practical sessions, lasting 1 day each, to give the participants the opportunity to do things, to work on our equipment, and to work on things we use every day in our laboratories. So we have 10 of them: initiation to fluid turbulence, granular media, red blood cell distributions, dense gravitational flows, fibrous material behavior, wave turbulence, membrane ultrafiltration processes, propagation of surges over complex topography, and diphasic flows. And that gives that's a good image of what we do in our labs. And this is my last part. I will talk a little bit about applications of our research. We are doing engineering sciences, and so we are strongly connected to the applications of our research results. We have identified 7 main applications area for which we have industrial contacts and collaborations. So I'll just give you these 7 applications area: energy production and storage, environmental management and risk assessment, of course, civil engineering, building materials, constructions, space, aeronautics and propulsion for the people working with fluid mechanics mostly, process engineering, optimization, remediation and recycling of materials, biorefinery, bio-based products and biomass valorization, and engineering for human health. And what we have tried to do in 2013, when I arrived, was to reinforce this movement towards the application of our research and collaborations with industrial partners. And so we have launched a proof of concept and R&D internship call for proposals. It's just to help our colleague researchers take the first steps into the valorization of their research results and facilitate the connection with industrial partners. So what we do is, because most of the time when you meet an industrial, that is my job actually, I go to conferences or things like that, I talk about what we do in research, and I discuss with industrial partners on topics that could be of interest for them. And what we realize is that even if there is a good connection between our research and their problems, most of the time, if you don't do the first step, nothing happens, because people don't know each other, they have never been working together. So you need to encourage this first step. And one of the way we wanted to do it, to try it, was to give them a human resource, because if they don't go together at first, it's just because they don't have time to. And what we do is, okay, it seems that it matches between you two. We give you an intern student, 6 months. You build up a little topic, you start working together with the student, and after 6 months, we get together, discuss, and see what we do. And actually it worked. Because we have financed among 50 projects so far, and among them 15 led to a PhD on the topic. So after the internship, the people carried out their collaboration and obtained a PhD finance. 8 of them were supported by the Linxium company. I don't know whether you know this, but that's a company here in Grenoble financing innovation and technology maturation. 6 patents were registered, 3 startup companies were created, and finally the return on investment for us is 3.3 million euro when we invested 126,000 euros. So that's good, it works. But beyond the figures, what's interesting is that most of the time, when you give the opportunity to an industrial and a researcher to go together, something happens thereafter. But you have to start the thing. Again, examples of what we have been doing. This deals with the hydrodynamics of a pneumatic agitator from methanization processes. So that's in waste recycling. Oh, I can change the slides here. Oh, that's great. Yeah, but I'm going the wrong way. Sorry. Yeah, this one. So yeah, this was an R&D internship because the laboratory had an industrial partner he wanted to work with. And finally what they did is a PhD together with a co-funding by the company. They obtained a government lump of money to start the PhD, and the company was involved in the financing the environment. This one deals with the rheology of rock glacier under climate change. So this is a proof of concept internship. It means that there was no industrial partner at the beginning, but the researcher had the idea that this research could be of interest for industry later. We actually have 2 kinds of internships. Whether you have a partner, an industrial partner at the beginning and you want to start working with it, whether you don't have one, but you have an idea that could be of interest for industry, and you just want to try to do what we call a proof of concept, to prove that your concept is of interest. In both cases, the idea is to go to valorization of your research results. And this led to a PhD again, funded by the French Research Ministry. Without this internship, the colleague researchers from Tec21 wouldn't have obtained the results to build up a strong enough paper and obtained a French bursary. This one deals with the characterization of liquefiable soils. And this is R&D because there was an industrial partner at the beginning. And after the internship, the company decided to finance a PhD and to hire it thereafter. This one is a proof of concept again, and 2 of our laboratories wanted to get together to see whether they could do what they call that again, atomic layer deposition on cellulosic materials to see whether they could change their property and make something water resistant or whatever. And it worked actually. And the outcome is that they went to Linxium, the company, the tech transfer office. They got financing, and finally they created a startup that is currently 10 persons working in it. And the last word about this platform, which stands for Processes, Environment and Industry. That's a big place where we work on clean processes and environmental issues. So we have 105,000 1,400 square meter. And what we do here again is to host teaching and education. Of course, research progress as well, research project as well. And we also host startup companies. What we do is we help young researchers who created a startup to live during the first year in a favorable environment to develop their research and technology. 50 people on site this year from startup companies. And that's just, again, examples of projects that we have. This one deals with ultrasound-enhanced filtration processes. This one you know well because it's from 3SR Lab, dealing with the mechanics of bio-based materials. And this is just examples of startups that we have on the platform. This one deals with the functionalization for cellulosic materials. And this one is doing recycling of solar panels. And that's my conclusion. So our LabX is multidisciplinary by nature because you have seen that we are working at different scales and on different physics. Since 2012, we have worked to try and strengthen the interactions between our partner laboratories. Our call for research and proposal involves that at least 2 laboratories must collaborate together. So that's mandatory for us. We also organize workshops to gather the community and build up scientific roadmaps on different topics. We've done it on biorefinery as well as on artificial intelligence. So we try to have our researchers talking to each other. We have been doing co-funding with other structures to encourage research collaboration with other disciplines like chemistry or informatics. And we also have a global communication, which means that all the PhD defenses or seminars are announced to the whole perimeter. And we also organize scientific days on multiphysics problems with speakers from various disciplines. And finally, more than 100 fundamental research projects were funded, involving a collaboration between our laboratories. 600 articles were published, and more than a third with co-authors from at least 2 laboratories from Tec21. We have been renewed twice since our creation, and we have included 2 new laboratories recently to work with in our consortium. So that's quite a good thing finally. And I'm done. Thank you.